I'm just going to give you a few tips today that might help you on Lab 2. I'm going to grab some data from a problem that is different from the one you will work with. So I'm going to use the data from number 12 in section 7.3. I'll hit the StatCrunch media link to open it in StatCrunch. So now I have a sample of 25 values. The first thing I'll do is demonstrate the QQ plot. If I go to Graph, QQ plot, I'll select the column and select correlation statistic. Now, the normal quantiles on y-axis, the technology step-by-step says to click that. I would say do not click that box, don't select it. It will reverse the axes and you will have trouble comparing your graph adequately to some sample graphs that I've provided in the lab. So then include your labels, title, and whatnot. Click compute, and you should have a correlation coefficient at the top with your normal quantiles along the horizontal axis and your observed values along the vertical axis. And of course, as usual, we will save all of our results from the options menu, and we will then compile them in StatCrunch reports. So we'll close that. The next thing I want to do is demonstrate a histogram with an overlaid normal distribution. So we'll say histogram, select the column, and then we can use frequency, relative frequency, or density. They all pretty much look the same. So I'm just going to leave it at frequency. If you leave the bins blank, then StatCrunch will just use the bins that it thinks will give you the best display. So that's not particularly crucial. And what we're going to do is kind of skip that, and then overlay distribution, we'll select normal, and we will not specify the mean and standard deviation. What that allows StatCrunch to do is calculate the mean and standard deviation of the sample that you've provided and use that mean and standard deviation to determine the parameters of the normal curve. And then, of course, you might want to include the mean and median markers. Those are always a good guide. And then, of course, labels and title. And we can compute. So you'll have something that looks like this: mean and standard deviation at the top, your labels across the bottom, frequency, relative frequency, or density up the vertical axis, and then you'll see the normal probability density function here overlaid on top of the histogram. So you can see if you hover on the normal curve, it gives you the mean and standard deviation. And so we can see all those features. Now options, save our result, and close. And the other thing I wanted to show you is under stat, the calculators. We'll use the normal calculator today. And the normal calculator allows you to do standard calculations, which would be less than a particular specified value, greater than a particular, this is actually greater than or equal to a particular value. So these are called tail areas. So we have the left tail area here. We have the right tail area here. We can either specify a cutoff value, like for example 0.5, and get a right tail area, which also would be the proportion or the probability associated with that cutoff value in the right tail. So for example, this would be considered the upper 31%, for example, or what we would say is that the probability that x is greater than or equal to 0.5 is 0.31, and so on. So we have those interpretations. You can specify a mean and standard deviation. 0 and 1 would be the mean and standard deviation for the standard normal distribution. If we put in one like 50 for the mean and then not 0.5, maybe 5 for the standard deviation, if we want to get the probability that x is greater than or equal to, for example, 56, we've got something like this. We see the right tail area is 0.115 approximately. So you've got those, and then of course you can do the between as well. You can also specify a given area and then receive the cutoff value back. Now options save. If I save my result, it will allow me to save a static image of my result here and then calculate again. Let's say I want to find the right tail area of 0.2, or I want to find the cutoff value for a right tail area of 0.2. then I type that in and so on. Now I have a new result. I'll save it again, and again it saves a new static image. So you can repeatedly save images from these calculations as well so that you can include them in your reports. Now, the other thing, I just want to do a quick recap of reports. So I'm going to say StatCrunch, open statcrunch.com, and I'll go to my StatCrunch, and we'll go to reports. Oh, that's results. Let me go to reports. Okay, so in reports, notice I have my lab 1. I don't have a lab 2 in there because I haven't completed the whole lab as a compiled report in this demo. But just as a reminder, what we'll do is create a new report. And don't forget, you will have, so we'll have a title. We'll do Lab 2, and then oops, my name, or you would put your name. I want to select share with everyone. This is so that I will be able to follow the link that you provide me. You don't need to provide tags. Now remember, any questions that you need to provide written answers for, you'll answer those here in the body of the lab. You'll include your results attached, hopefully in sequential order, so they're easy for me to do. Everybody did a great job with that last time. And also your data sets. We have a couple of data sets or worksheets that we'll need to attach here. So don't forget to save your data. Let me go back to that tab for a moment and remind you how. If you go to Data, Save, that will save the data worksheet that you have here. So just a reminder on how to do that. So we'll attach our data sets, and then at the bottom just save. I'll just save this one. It'll be blank. But now if I am now in this in my Lab 2 area, I can select Mail, and I will type in, of course, my email address, the k.mcgowan@nmsu.edu, and then the message optional, but make sure that you say send link only. That allows me to follow the link and view your lab within StatCrunch. So that's about it, and if you have any additional questions, please email me, and good luck.